Hi, it's Ed from EHCC on behalf of TEC, and today's topic is external static pressure in conjunction with using an OEM fan table. What we can see on this slide is three different or separate manometers. Whichever one you feel more comfortable with, I would recommend that you use. Whether it contains a battery or it doesn't much matter. We don't need that precise of detail to take a static pressure measurement. One of the things that I'm going to say is not optional, is required as a static tip. Can you take a successful static pressure measurement with a straight piece of tubing? Yes, but it's not advisable. We're also going to need a hose or plural hoses. And as it says over here, we need something to make a hole in the duct or the furnace, potentially the air handler. What we have on this slide is simply a comparison between a furnace and an air handler. For simplicity's sake, we're going to do our example today on a furnace. Real simple diagram: return duct, filter, blower, heat exchanger, evaporator coil, supply duct. You take something to make a hole in the duct. In this case, we're going to use a drill. We're going to measure our static pressure at the exit of the furnace prior to the evaporator coil. So we're going to put a hole in an appropriate location. Be careful when you make that hole. There's danger abound. We also want to make a hole where we can measure that return static pressure. We grab our gauge. We insert a static tip at the exit to the furnace prior to the evaporator coil. We have 0.3 inches of water column or inches of H2O. We record that information. We take our hose and our static tip and we repeat the process in the appropriate location on the return side. In this case, we've measured 0.2 inches of H2O. We take those two numbers, we add them together, and what we are measuring is a delta P of 0.5. Quite simply, take that information and compare it to the OEM fan table. In this example, we have a standard induction motor that has 4 speeds. The furnace happened to be on medium low. That 1/2 inch or 0.5 inches of water column measurement, we intersect the two, and it shows us that we had 610 CFM moving across that furnace. Pretty straightforward. It is one of my favorite ways to estimate airflow. I wouldn't say it's the most precise, but I would say that it is probably one of the most common methods to estimate airflow. There's a lot of good things to say about it as far as cost effective. You don't need a lot of tools, fairly simple to do. And the agencies that we care about recognize it as a method to estimate airflow. There's some definite downsides to it, and its accuracy can be in question. Things have to be clean in order for it to be accurate. This is a test that we would prefer to do during a new install. And with that, I am going to pass it over to Bill Spohn from TruTech Tools. Bill's going to share some quick tips and some options for tools that you might be interested in. With that, I will look forward to seeing you next time.
Hey, thank you very much, Ed. Here's some quick tips about measuring external static pressure using the OEM fan table. Something to keep in mind here is OEM. What it stands for is Original Equipment Manufacturer. The manufacturer knows exactly the state of the parts, the way they were put into the system when they developed these tables that you'll be using. So it has to pretty much match right up with what they were using to get the optimal performance, the optimal results. They know the pressure response of the components in their system the way they made them in the factory. And that may even include things like motors. The replacement motor, if a replacement motor is chosen, it may not have exactly the same performance and the same characteristics and yield a little bit of variation in the result for this airflow measurement. You also want to make sure the system condition is the same as that the manufacturer tested, and it's usually right in their specifications of their fan table. You also want to use a good method to store the data and do all the math required. So basically, do your homework in the equipment and the tools you use. Now, speaking of tools you use, TruTech Tools is a good source for tools. The pricing shown here is January 2021 pricing. These are list prices. You can often get them for a little bit less money than these. But there's things available like the Testo 510i, which is a smart probe. It doesn't have a display on it. It's a good cost-effective choice for external static pressure measurements, as well as gas pressure, fuel pressure, kinds of thing, pressure drop. It does need to connect to a smart device through an app, a free app, but it also captures data. But it has a limited ability to measure other building pressures. Similar to the field piece, the SDM-N6, that's a really good gauge. It's got an additional feature of a furnace pressure testing option in it, and you can actually see the readings, the pressure readings on the screen. The TSI AP800 is a great micromanometer with high resolution. It's a very good option. It also has Bluetooth and it connects to an app. It can also data log onto an SD card. Then there's the TEC, the TEC DG8, which is a very highly accurate and highly stable micromanometer. One of the reasons it's so highly stable is because it has an auto zeroing function in it. It's a great little feature in it that keeps that rock solid, precise numbers. It also hooks up to the free TEC TrueFlow app, which will allow you to step through this process of making these measurements and collecting the data and doing the math for you. And you can also look forward to seeing this on the Measure Quick roadmap. The TEC DG8 is very accurate and can be used for so many different building pressure measurements, including room pressure measurements and combustion air zone measurements. So if you're looking for more information, you'll find it on the TEC HVAC Air Flow homepage. I want to thank our partners at the Energy Conservatory and Ed Janowiak, Steve, Bill, and Ed for helping us pull all this together and do some kind of service for the industry. We want to really make sure that you know how to do testing is the best way you can, the best way possible for your budget and your application. So I look forward to seeing you again and want to thank you for listening to this little excerpt, this little short video, this learning session on external static pressure in the OEM fan table.